Hello, good
Hello,
morning.
yeah. Good morning for you, but we are here already almost 3 p.m.
Nice, happy New Year 2021.
Happy New Year. Shall we start or wait for a while?
We are alone. There's nobody else.
Yeah. Attendees is only 19 now, I saw.
We can start, or we are waiting some people to connect.
Yeah, maybe we start at 14:45. So another 7 minutes. Wait a while.
Okay. In this case, I will try to look some graphic information I may need to help illustration.
Yes, better.
So let me find information. Las luces. Las luces en el salón.
Antonio, are you going to present cantilever wall or something like that?
Yes, we have to see two programs today: the cantilever wall and the box culvert. No, this is the two program we scheduled to show. I think. I don't. This was the program, no? Where this is what was programmed, no? So I suppose.
Yes, that's right.
Okay.
All right, I think we start.
Okay, let's start.
Ya, selamat sore Pak Ibu sekalian yang sudah ikut di dalam webinar ini. Ini merupakan seri yang kesekian dari webinar yang diselenggarakan tentang CYPE. Saya mempelajari software ini walaupun tidak detail, karena saya bukan ahli struktur, tapi saya juga mengerti tentang struktur banyak hal. Ini ternyata software yang sangat berguna dan relatif murah bila dibandingkan dengan yang CYPE dan lain-lain, dibandingkan dengan ITAPS, SAP dan yang lainnya, itu relatif lebih murah jauh, ya. Dan memang ini adalah software yang buat Indonesia relatif baru, tetapi tidak baru buat negara-negara yang sudah pakai ini, terutama negara-negara yang berbahasa Spanyol. Sekarang memang sudah juga mulai banyak digunakan di Malaysia dan di Asia lainnya seperti di Jepang dan lain-lain negara. Jadi mari kita mulai saja dengan yang hari ini mengenai cantilever, wall, dan box culvert. Jadi software ini sangat berguna, banyak alternatif yang bisa dilakukan dengan software ini. So, okay, I think that's a short introduction to the CYPE software. And then maybe Antonia, you can start now.
Okay. Okay, I have to share my windows now before how I share my windows. My windows is already shared or no?
Not yet.
Camera view, capture pantalla. I don't have the possibility to share my screen. This was okay. Now you can see my screen?
Yes.
Okay. Perfect. So don't show the web camera. Okay, so can you remove your web camera? Perfect. So good morning for everybody. Today we will try to see or present the program we call box culvert and the cantilever wall. No, these programs are they have the shortcut in the menu. We have to install the program in English like this, and we go to the structure chapter, and we can see the two programs. We see to the box culvert and reinforced concrete cantilever wall. We'll start with this program. So
By the way, I interrupt you for a while.
Okay.
I think when people buy, because I have question, right?
Yes.
Just the screen just now. Don't just now. The first one just now.
I go to the general menu, no? The general menu.
This is the general menu, right? Many people asking me when they buy the structural package, they should have all the software down below, right? When they buy the structural package, of CYPE software, then they will get CYPECAD, portal frame, CYPE 3D, CYPE Connect, embedded retaining wall, all those, right? All those appear on the screen. Is that right? When they buy,
I don't know. That is it depends the commercial transaction. No, normally if you buy all software of CYPE, you have the possibility to use this single program. If you buy all. But normally people don't buy all these. But you can, if you are using embedded retaining wall, you have to be specialist. So maybe the people who will make embed retaining wall don't make structure calculation. So they only need this one. So it depends the need of the engineer, no? It is a specialized program. Maybe normally when you have CYPE 3D with the joint connection, automatically you have CYPE Connect. But if you don't need CYPE 3D and you want to make a calculation of connection separately with the program, that's why you only buy CYPE Connect. But normally when you buy CYPE 3D with all the possibility, you have CYPE Connect automatically. No? When you are using CYPECAD, you buy CYPECAD, you have only also the possibility to make calculation of wall with working like cantilever wall. You just need to draw a floor in the top. So maybe you don't need to buy the cantilever wall. No, so that depends of if you are making specialized use of some feature of the program, or you are a generalist, you want to have all. But in any case, when you buy all, you have all. And when you buy only CYPE 3D, you don't have reinforced concrete cantilever because it's a different program.
Okay.
I continue?
Yes, you continue.
Okay. So we'll start with the first one, reinforced concrete cantilever wall. The name of the program will tell you that we only make calculation for wall. We have the diagram forces like a cantilever. No, this is the basic way. So let's enter in the program. We can, like every time, go to see is the example, which is to the introduction, and we'll create a case. Let me close this. Okay, we have the general. Well, this is the interface of this program. It shows us a general section of the wall we introduce, and the down left part of the window, we will have the possibility to go to the data entry tab or the reinforcement entry tab to see the result of the reinforcement. Let's stay in the data entry and try to introduce. The first option we have to do to use the program is to fix the code. Differently with CYPECAD, we often go to project general data. We don't have this option. So it's very important to remember that in the configuration command, we have the possibility to go and choose the code we want to use. In this case, we have the implemented code. So we can choose the code we want to use. I don't know, in this case, we will use the Malaysia, no? This will be the...
No, I think better to use the ACI code. We are not following Malaysia.
Okay. Well, in this case, we choose the IC user, and we can save it. So the next job, we take this configuration. This is the first, maybe the first command we have to do. But when we are making the second job, program remind that we select the default code. So, and we can come back, of course, to material. Well, the type, normally the type will permit us to change is if we want fixed. Fixed means that we don't want to know nothing about the foundation. We can choose strip footing, which is normally the option we used to do, or the capping beam to have the pile, the pile cap, no, to be distributed with two parallel piles alineation. So we left this default option, and the next thing to do is to go to the soil and fix the general data. We'll see it in the next job. I'm just making a general introduction of the program. And when we fix the soil, we can also edit different layer to fix parameter of the layer we have. We can go to the wall and edit the geometry, the thickness, the bottom thickness to make it variable. And we can go to create different files where we change the way the soil act. When this information is done, we can go directly to analyze and force the program to give us some result, like axial diagram, shear diagram, bending moment, earth pressure, hydrostatic, and so we can see it in the windows. But normally people go direct to make design all. No, design all means that the program will make the design of the reinforcement and also of the footing we need. So when this is done, we have the possibility to make check for the element where we have this node will permit us to see the different verification which will be made. Basically, we have in the wall all this check, but we have also in the footing the verification of slipping, of footing bending. We have the safety factor against overturning, sliding. So the program will give, this is very important, of this type of wall, to know where we have safety or not. So when the program give with the geometrical solution, we can go to the reinforcement and to see the different reinforcement which was fixed. We have the possibility also to make addition and change the geometry and spice and verify the reinforcement were fixed to the program. So this is a general introduction. Like another program of CYPE, we have the possibility to make output, general output for all the chapter we choose, and the output will be exported normally to the standard format we usually make. In the plan creation, we have also this possibility to permit the program to generate drawing. So this is the drawing which was generated with a table with the different type of reinforcement the program generated the way to cut the bar. With this introduction, let me start a new job so we can go a little more detail with the information of the case. So very simple. We have a data entry, a reinforcement. It's a simple cantilever wall where we'll have the possibility to change variable of the geometry of the wall. The foundation will have the parameter of the soils, and also we can go to the project. We have the possibility to change material we use, option the program used to make the verification, like the safety factor of sliding, overturning. We can adapt the special case we want to make. This is some option to permit the program to take different type of way of making the reinforcement, without continuity in bar spacing, with all this will be. Let's start a new job. Normally, we can start it by 0, or we can use assistant. If we are starting the first time, I beg you to use this option. It will permit you to have more aid while putting information. So we have this assistant, which is very simple. You see that we can control the geometry, the soil, and the load. When starting with the geometry, we have to fix information like the height. We want to resolve the problem we have in mind. So we can leave this value or we can change it. No problem. That depends on you. You can, if the wall is high, maybe you want to optimize the section and make a variable, and you can choose it. This different option. The footing we will with tools and helps. We'll put this option. So we have tools and helps in the footing of the foundation we are making. So we go to the next item, which is the soil, and we can choose in the backfill one of the proposal the program gives us. And when we choose the type, it can be gravel, but no problem. If you have a specific geotechnical information, you can choose. You can choose in these windows someone which is similar, and later you can change parameter. We'll see how to change the parameter of the type of the soil we choose. No. In the footing, we put the allowable bearing pressure to permit the program to make comparison, no, with the calculator pressure. So in some cases, maybe we don't want to verify the sliding. In this case, we will make it. It's not normal, no, it's not current. So we allow the program to make the verification of the sliding. Later, we'll see how we can uncheck this option. So we continue. We can have some loads on the top of the soil. In this case, we have this type. No load means that we don't have any load. Traffic, light traffic, we meet that program. We generate half ton per meter square. Heavy, we put a high value, and we can change it. So maybe we don't have load in this case on the top place. And with this information, we have the general parameter to the program to generate the start of the problem we make. So if we come back to the project type, we have the possibility to change. In this case, we want the solution of the foundation with straight footing, so we don't change this. We go back to the project material. If we want to fix the material, a different material, according to the case we have, we can change it. The steel grade also, the cover will need. So this will be very important for the design of the reinforcement and making plan, of course. So we come back to the project. We go to general data. This is the point we can change the height if we make a mistake during the assistant. When the assistant finish, it transmits all information for the program, and you can change it in the particular windows where you are. So we don't change it. We left the solution like this. Normally, the program make the calculation of 1 meter. The longitudinal 1 meter, but we can obtain the medition. We can obtain the measurement for the wall length on this plan, or the plan we have. No, we can have 5 meters and we join. So the program will take special care for the cut of the bar. So we accept that. Yes, can you repeat, please?
Wall level, what is that for?
Let's go to, I was in the general data. Yeah, what is the question, please? You are asking this, no? Height of the wall above the ground level, no? This is a question? Well, if this is the question, that means that you can have the starting of the ground level a little down of the top of the wall. Not all the case, we can have the ground at the same point of the end of the wall. This will permit us to push down the level to start the pushing of the soil. No, it's not frequent, so but we have this possibility, of course. Let me continue with the load option. In the load option, in this point, we decide the type of pressure will be generated. In the case of the backfill, normally in this type of wall, cantilever wall, is current to choose the active pressure. In the case we have some type of element with avoid the movement of the up part of the wall, we change it to at rest. No, in this case, and in the infill lateral pressure in this side and the left side, to permit the sliding of the wall, we use passive pressure. So normally the default option is the correct value to choose. If we have seismic forces, we can permit the program to take the Mononobe-Okabe equation to generate these forces in taking account the acceleration we input and the percentage of the this. We have an error in this point in the live load. This we have to this word is not correct. Surcharge. This may be called live load. No, live load considered with seismic. We will use the 18% of the charge to generate the horizontal seismic force. But this word I have to take note, so the guys will make correction in the English version. Sure. Okay, but in this case, I don't choose seismic value. And we have this. If we go to the soil option, well, we can come here. We didn't talk about option. If we go to option, we see that we have a parameter. We will change the quantities the program gives us. If we add a 10% of loss percentage of fabrication, we can consider all different parameters for the sliding verification, but these values are already good. And we have some particular parameter for the design of the wall, design the wall with a constant thickness. This was when the program tried to see what is the suitable width. If this option is false, it will make it to be constant. The continuity of number of bars. These are some settings we permit to have some automatic result directly. If we go to the foundation tab, we'll also have the possibility to insert in the way program will take the design of the foundation. In this case, the tubes overhang twice that of the hill. No, that is a normal option to design. If we go to the footing, in the case we have footing, we can use the design like a flexible or like a rigid. In this case, it's normal to use like a flexible, so the thickness will be lesser. Well, this is not the case we have in the job. In the case we have in the job is foundation. So we accept. If we think that these parameters will change, we would like to use it in the next job, we have to save it like default option. No? So the next time program we use it. We have also in the reinforcement table the possibility, of course, to see the type of reinforcement which are available, and the program will use it to make the design. If we want to add another combination, we can do it. But I think that this is enough for the typical job we are doing. So with this option, normally we don't come to see this in any job. When we know what the program do, it's sufficient. See. There is some message. No. This is okay. So we go next to the next menu. We go to soil. In the general data, we can see some parameter. The ground level elevation, we already talked in the general windows. We will not change it because we want the top part of the wall to match the top part of the ground. We can in case to release the pressure, if we have rock in the deepness, we can say in what height we have. This is not often, and we have the rock like this, but this is not often. So let's go back. General data, so we can decrease the pressure according to the real situation we have in the job. So we have the sloped angle, we can have a sloped angle centigrade, and we have a distance 1 meter. You see what we change. So this will permit us some case to make accurate the definition of the soil. No, so this we remove it 0. If we have embankment height, we can also indicate this. The depth of the water table. Also, we can also put the depth. So the pressure will change in this point. So we have many options to fix some possibility. No, in this case, we have the depth of the water. We already talked about it. With infill soil, we can put some soil on top of the foundation to help the sliding in case we have it. If we don't have it, no, we have also the possibility to take a drainage loss. No, if we have a 100%, that means that we have a very good drainage. All water go out, so there will not be increase of pressure. In the case we have of passive pressure, we can take a 100% or 50% or the percentage we want to avoid or to help us of the sliding. This the engineer decide this. We have also the possibility to change the allowable bearing pressure if we will not agree with this value or want to change it. And if we want to make the verification of the sliding, this button must be checked. You see that the program help us and give us the aid in any window, so we can know how this parameter can affect the calculation we make. So this will be very important. We have also general aid in this point. If we make a click in this button, we can have a special aid of all the parameters we need, no? So this is the way the user can have specific information of the parameter is changing. So let's come back here, but I want to go to the soil general data. I want to remove this value. So I accept, okay. When we go to the soil, we have the possibility to create a new layer or edit a layer which is already put. You remember in the starting, when we use the assistant program, force us to use some generic type of soil. But if we have a specific soil, maybe we want to change the submerged unit weight, or maybe we want to change the internal frictional angle, or we want to change the internal friction angle to be different. So this parameter is very important to generate the pressure. And with every time, even the program give us some standard value, it's very important to input value we are in the geotechnical inform, no? So that's why we have the possibility when we go to the soil edit layer, we can fix properly the parameter. If we have instead of 30, we have 22, we have to input the value. If we have a little of cohesion, we have to introduce it to help us. If we don't have cohesion, we don't put it, of course. So we see that all will be perfectly. No, we have parameter to copper layer, to edit layer, hatching. But this is simply for changing the different way of the hatching of the soil. Well, it's important relatively. And we can go to the phase to change something during the life of the wall. Maybe we have some variable forces. No, we can make load incremental. We can add at the top of this vertical load. Maybe we have 1 ton, and in the dead load, and we can put in the live load maybe some value. I will remove it. I'll put vertical load 2 ton, and I don't have increased load. This will be sufficient. You see, program will show you this load in the windows. So now we go to the analysis. We already see and force the design of all. Let us see some check. We don't go, so we go to the down point of verification. to see what is. And according to the ASI, we need to have a cover which is minimum 7.5 centimeters to verify. So the way to verify that we can do if we come back to the project and we go to the material and change the minimum value. Okay, and go back to the analysis and let's see what's happened. The cover of lateral. What I'm talking about, lateral of footing. Project material lateral. This is my mistake. If we want to verify it, this if we don't, if we take the different decision like engineer, we can go on with. Say I make the changes and immediately the program take it account and verify the condition. So, well, this is the solution. If we need to change some geometry, we can do it with edit spam foundation. We go and change the geometrical. If this is 140, we change it to 135 like this. Program accept this modification, and we can force the program to design the geometry. So the program, we don't change the geometry and we try to design it to give the reinforcement according to the new. If we have some problem of overtuning, or we have problem of slicing, the program we advise us. No, so let's check. So we see that this solution is correct. So the next step, of course, is go to the reinforcement to try to check if we agree with this. We can make. Some people need this reinforcement to continue like this, but in this case, it's not necessary. So if we want to force the program to do it, so let's go to and we change over pump footing. So there's some modification we can make it. No, if we want to surcharge this reinforcement, we do it like this. We can modify diameter and separation. Of course, we have a button will permit to change the changing we are doing. And now we can finish by making, of course, the report. Will show us the course selected, the load input, the general data, the soil description, the geometry, and the phase diagram. We consider numerical value of axial shear, bending, air pressure, hydrostatic. In this case, we don't have it. That's why the combination make to the design report selection, description of reinforcement according to the different element report. The checks which one make for the two element with the vertical element and the foundation element. So, and this is the stability check where cost flavor is some bonus the program give us. This in this case is if I come back to this point, I choose analyze and we choose worst case failure plan. Is an additional verification the program give us. You see, program in this case try to analyze choosing the center and a curve for the slicing of all the, and this is the poorest point. This point give us a coefficient of security of 1.4, which is lesser than 1.6. That means that it doesn't work. Normally, this is a theoretical computation of this. So maybe you can say that this wall doesn't work like this, but we don't have the coefficient of the security, the factor security, which is higher than 1.6. How can we do to arrange that? We have to think that the ground is not homogeneous. No? It's irregular. If we have some stone there, we make it, this factor will be higher. Or we can also try, normally we don't take account in the soil, we don't take account the cohesion. So if we try to, then in the reality, we have maybe some cohesion to permit us to pass this verification. Let's try to put 1 ton. And we go back to analysis, work check. See, with only that changes, we see that we increase the factor to 236. That means that it works. So take care about this verification because it's a theoretical value. That's why the program make it in a second. It doesn't make it with the general check. It make it apart, no? So the engineer can understand and take a correct decision to make it to verify. So, to continue, we force the creation of the plan and add, of course, the reinforcement. We can add the title bar. So we see the geometry in this point, the reinforcement in this point, the table for the measurement in this point. That's all for this program. It's very, very simple, but it uses a high mathematical way to generate the pressure. Not what is, this is the point which is difficult normally when you have to make it by hand, no? To generate the pressure according to different type of cases you can have, no? So when we go to the bending or the pressure, so we see that the fact that I introduce the equation make that the pressure will be effective effective to a certain height. So if I change soil, edit layer, and remove this equation, we see immediately the changes, no, in the pressure of the head pressure start at the top. For me, this is enough for this program. If you have some question, you can make it before I change to the box culvert. Any question?
How do you make the layer soil?
Yes, can you repeat?
How do you make the layer soil if you have a 2-layer or 3-layer of soil?
Yes. Let's come back. See, you just come to the soil new layer, no? You give a name, second layer. When the name is given, you give the depth 1 meter and change parameter. You have the second layer. If you want another soil new layer, in this case, third layer, deep, 3 meter, and so on. You can create all the different layer you want. This is not a problem. Normally with 3 meter is very different, difficult to have changes, no, of soil.
Yeah, by now, just now you show the reinforcement, right? When reinforcement, the hex time in number 3, what is the diameter of the steel? Then how do we see the diameter of the steel?
In the reinforcement, you need You in this point, no? This is
the
the
number 3. What does it mean?
This is because I choose the ASCII representation. If we choose a different representation, this go according to the how to say the ASCII unit of representation of reinforcement. If you change the let's go back to this.
Normally, what we use over here, like D16, that's mean diameter 16.
Mm-hmm. Yes, because it go. Let's see this.
Your number 6 like that has times 6. What is the diameter?
I don't have the equivalence. I have to find it, but I don't manage this diameter. No, in some case we have the I don't. I think the Paria 6 is something near to 20 millimeter. But we can say there is some code because I choose this one. Maybe there is another code. Let's try something. Error code. Un moment. I have in CYPE because now we are working in house equivalent of this diameter. But normally I don't work with this type of design or. So you want to see like that, no? That you because it depends.
Does that mean like 10 millimeter at 25 centimeter distance? Is that right?
Yeah, this is the displacement and the diameter. And when we change the ASCII, we have English nomenclature of diameter. No, if we have the equivalent table, we can choose it. Normally, when we use this code, because we also manage with people who know how to use this type of nomenclature. No, this is the way we think it. Okay.
Okay.
Well, but in this case, we close this. And we go to the Boskulver. Now, the Boskulver is a specific program which permit us to, let's see what's happening, see that I have it. It's a program which is prepared to make analysis of structure of small bridges, no concrete bridges with the span normally is no more than 12 meter, 30 meter. That we will need another technology of pre-stress, no. So it's very important to understand which type of element we'll manage. So before I start to show the program, I will give you a general view. Let me show you some image I prepare. No, this right, just single message. This. Even this is in French, no problem. So this is a general way. We call Boskulver, or the interpretation of CYPE of Boskulver is a type of bridge we will have every time a mat foundation. Every time a mat foundation, we can have we will have also on top of the mat foundation a flat slab. And we have at the end walls, no? With walls in the light and red. And optionally, we can have wings. So permit me to permit me. Somebody want to make consultation, so I close it. So I was giving a general explication of the type of element. The interpretation of Boskulver with CYPE means that we have a flat slab on the top, we have a mat foundation on the bottom, And optionally, we can have wings. We avoid the soil to come back to disturb the entry of the bottom. We can have also division, who permit us to have a very big span. The division reduce the force in the slab, no, in this case. Optionally, we can have it. So we can have also a different module. The interaction between two modules are null. We don't have interaction. We can draw different modules. In this case, we have 3 modules, 1, 2, 3, or we can have only 1. But there's no connection between 2 modules because we think that the construction are being made separately. No, this is very important. And when you make wings, you can optimize the wings by creating different type of span, and program will take it like rectangular element to approximate the variation. This is the general way to understand what we call a box culvert. This forced me to make a question. The image we are looking about, we can make it with the program box culvert. The response is no. Why is no? Because we verify that we have walls, we verify that we have flat slab, but we don't have a mat foundation. This is the model I show at the dry to understand the analyzed structure. So this situation make us to think that the solution to resolve this, we have to use CYPECAD. We verify this condition. With CYPECAD, we are not forced to introduce a mat foundation. We can have a foundation for the different wall like this. So that's why I put this image, no, to the user to know how to identify which problem can be resolved with the box culvert or can be resolved with another program. So with this small introduction, we can go maybe to the help about in internet, and we can see the image. No, the image verify what I just say. We have a flat slab. We have a mat which is hidden with the rod, and we have the wings. No, this is a typical solution we can give with this program. Now let's see how the program is being formatted. No, we have in the upper part the menu to permit us to go to the typical file of CYPE, where we have the project to manage material, general data, option, reinforcement table, view. We have plan to generate the geometry. We see how to use it. Also to manage the different level, the geometry, material geometry, how to introduce truck load, strip load, and to make the analyze. No, the module, the center module will be analyzed like a finite element, and the wings will be analyzed of course like the cantilever. No, this is the way we make. At the bottom part we have edit, force, reinforcement. With the edit, we make the addition of this geometry. This is a simple example, like we have the possibility to load the example CYPE have. So this is a simple example we have. When we go to the project, we see 3D view. In this case, we didn't have the wings. We don't need wings, so there are no wings in this case. When we make analyze, we can go to see about the loads we have. If we go to the truck load, we make addition. We can see the truck load which is being generated, no, to permit to transmit the print of the lorry in the module, so we can have different behavior. So we have also the strip load which is being introduced. So if we make the analyze, design all, we come back later when we make a particular case. We have also the verification which is being made, and we can go to the force tab to see how with finite element the different case load. In this case, we can see the truck at position 1 to see where the bending moment are greater or no in the windows, no? So, and we can go, of course, in the reinforcement. In this case, we have a lot of elements, so we can go to the hierarchical windows to go to the module, and the module is being composed to the top slab, we already said, the bottom slab, in this case is the mat foundation, and a section where we can, in the same way we already talked about, we can make modification of the reinforcement to verify. And finally, we can make output by making a report and, of course, plan. So this will be the general way to work with the program. With this simple introduction, of course, with this simple introduction, we will start a new job. Remember, the code will be changed in this point. Like the same manner we already talked about the cantilever program. So let's start a new job. In this case also, we have an assistant to help the user. So we do assistant for straight curve. We have an assistant who permit us to change the geometry. In this case, we can leave the same, the proposal geometry, internal height, 4.5, the clear span, we put 5 meters, the length axle is very clear, and the geometry, the information they ask us. We go to the wing wall. We said that optionally the program can give us the possibility to generate the wings. So if we don't want wings to be generated, we simply remove this. But in this case, we'll leave it. And the way to make the orientation of the wings will be according to this option. We can make it extended or parallel. Normally, when it is extended and we have 0 degree, we have like this. If we want to open it about this point, we'll put maybe 15 degree. If not, it will be parallel. So this is the generation of the wing walls, and we continue. The top rod. Normally, this box culvert, we make the design because we need some infrastructure, some road to be passed on top of the box culvert. This is the way to make situation where the print of the road will be placed. So if we put 0, that means that the road will pass in the center of the slab, the top slab, of course. If we want to put it at the right, and the angle, if it's orthogonal, we put 0, the width of the road, and of course the height above the bottom slab. This will permit the program to add additional soil load on top of the box culvert. In these windows, in the 4th parameter, we have to give information about the type of different soil we'll have, no? The base soil and the, how to say, relleno, the fill soil. We have the base soil and the base soil and the filling of the soil, no? We'll need once we make the execution of the different module. So in the case of the base soil, we choose what we need to this. Later, we can also change the specific parameter. And in the case of infill type R, we choose the one we need. The slope angle is the way the program will make the distribution or the transfer of the load, no, in the bottom. So normally this value is acceptable. and we go to the load generation. We have different type of load generation. If this one didn't satisfy us, we will have the possibility to change it. You see that we generate 500 ton meter in the two bottom slab. That if we don't want this option, we are making projection. We don't permit traffic to pass on the bottom. We don't choose this option, but we can. This is optional. Later we can change it. With this information, we avoid to enter in the plan and try and start to draw the lateral wall, lateral left wall, lateral right wall, because program already do this design. This is what it do. So if we go to the project 3D, when you use the assistant, you don't need to draw it, because all information you give permit of the program to generate this information. You have the thickness of the space between the top of the slab and the road, no, the filling. You have to put, the program show you this information. You have all, which is accotated. You have the top, the indication of the top level, so you can see it in this point. And you can verify which type of truck load program generate. According to the height, the width of the module, they generate one. This is the printing of the type of the truck we have and the load. So, but with 3 positions, you see, we have a position, one in the center and the left. The different position will permit the program to take appropriate forces in the wall, in the span, in the slab, or in the another wall. No, this maybe in this condition is correct. So if we have 2 traffic way, we'll have one in this direction and one in the other direction to repeat this configuration. Very important when we are talking about the truck load. When we want to make another truck load, you see that I can choose a point. This is no sense because we have to put the truck load on top of the module, but no problem. That will permit us to see this is the direction of the truck load, and we decide how many positions we have. No, I choose 2, and we can take a proposal printed truck, or we can go to the edition and generate the proper one we have. This is maybe the very important part of the program, because it permits the user to generate the print of a special load, and it can, when it changes the position of any print and the load, it can put it in the Bible, in the library, to use it later. No, this is the option. I can import from library, export of library. I will import predefined data. Let us go to capacity truck. This one, you see, is different, no? So I will use this one. I have 2 positions, and program will take it account. But I just show this to show more possibility. I will delete this and left only the 2 one it was generated with our case. We can see another additional load we can put, or see what the assistant do of us. This is the dead load, the live load, the put in the place we need, no, to take account to design of the module, of element of the module we have. So this is the way we are trying to verify what the assistant do for us, and we can change it. If this geometry we don't agree with it, we can come with the plan menu and move lateral point. We can take this point and move it if we have a template. If we have time later, we'll try to use a template to draw another case. Okay. So all information can be changed. If we come back to the project, we go to the material, we see that it's similar like the cantilever world. The parameter of concrete, steel grade, exposition, all this can be changed. If we come back with the project, we go to general data. We have different parameters. We will be very important for the calculation. We can start to the subgrade modulus. We say that the bottom is a mud foundation. So when we choose a type of a standard type of soil, the program transfer this information. But if we have special information, we can change it, no, by changing this point. We can also, in the field, we have the apparent unit weight to generate the load in the lateral wall. This will be the parameter to change it. This is a parameter for the base soil, and this will be the parameter for the filling, no, or. So, and the way to manage the geometry by height, we already see to know the level where we will have the road will be by height, and the lateral well adjustment will be internal surface. So this is another way to generate load for the standard element. In this case, the bottom uniform load, and the bottom we already tell to the program, it shows the value to be changed, and we have the of course the cover for element. If we come back to the project and we go to option, we have the possibility to change some option for the design of the and evaluation of the reinforcement. This is a normal case. No program try to give a general base reinforcement, and later this reinforcement will be 14%, and we have punctual reinforcement. At some point, we have to cover the 100%, no, 100%. This is the normal way. It's similar like what we do in the math foundation in CYPECAD. So with this parameter, we can force the program now to design all, and program make determination of forces. When we have some check, we don't work. We'll see what's working now. What's wrong about this? We have a problem which is relative, no, we maximum share. We have to verify the program don't give reinforcement of the shear forces on the wall, because in this type of bridge is very amber resource, no, to make shear reinforcement. So the program make the verification without the shear reinforcement. We have a verification of 96%. So maybe this percentage, this 3.7% we don't verify is due to the method, no, the finite element. But for me, it's verifying. We don't have to change nothing to verify that. If we have some problem, maybe in 90%, lesser than 90%, that will be a very significant, that we have to increase the thickness of the wall, so we don't need to put reinforcement. But in this case, we can accept the solution. So you see that program make the design of the footing, make it increasing like this, so we don't need to make it uniform. And if we go to the reinforcement, we can see that in this case we have more element, no, we have a module, we have a left initial wing, maybe we'll come back to the edit. So we have 4 wings. If we go to left to right, we meet at the entry, the right entry wing, the end right final right wing, final left wing and initial left wing. That means that if we make organization of hierarchically, we have the possibility to go directly for the element we need. If we go to the module, this is the module. We have in the module information of the top left, the top button, and we have the section. To make single edition, we only know how to do it. If we go to the left initial wing, we choose a section. We have something similar to the cantilever word, to change and to see. Of course, when we make verification, in this case, all thing is okay. We can force the takeoff of the report, where we have all information about the geometry, charges, forces, typical information we used to give, and possibility to export to normal. And we can come back to the plan generation. Okay. So we have the geometry, we improved, we have the section of the module, and we have the schedule of the reinforcement, the different section of the wings, which make it variable to the execution. This is the example. Let's try to make another case, but this time, instead of using using the assistant, we have to make it directly, So permit me to go to File, New. Maybe we use CAD input. In this case, I will use none, so we try to manage. If we choose none, we'll be forced to pass to the material generation and to change some parameters like the ground information, but this is not very important in this case. Now we are in the starting point, to try to input the geometry of the case we have. If we can start to draw it like directly like this, we go to the plan, new lateral wall, right? I can start like this point. You see, I will come back to plan. We talk a lateral left, new left lateral wall. So when I start this 1.2, 3, right click, finish. If I come back with new right lateral wall, I can start like this and finish like this. If I come back with plan, I have the possibility to create new join face. So if I join this point with this, and join new join, and this one with this information, a program can generate the geometry. Maybe this is what it make it very quickly. So this is, we have to consider this, it's very important. So now we know how the program works. Permit me to delete all these elements. And there are some elements like this. We can add a new join, This in the geometry. a division. We can add this and create a new division. You see, in this point, we, in certain case, would make to reduce the spam. This is a small demonstration how the fast geometry of this. Let's come back to the plan and delete all elements we introduce. Plan, delete lateral walls. We are the starting point. In this case, we want to use a template. Will be the usual case when what is complex, no? But a simple.
Antonio, are you talking or not? There is no voice. Antonio? Antonio, no voice. Cannot hear you, Antonio. Antonio, there is no voice of you. Antonio? Antonio, there is no voice of you.
Hi.
Yeah.
Can you hear?
Now, okay.
Yes. I don't know in which point you lost me.
Since from the start of this.
From the start of this. This is the way to make introduction by using a template, no? I use a template to draw the left and the right lateral wall. When it is drawn like this, I will try to not see the template. So we see the line of the lateral wall. Now I continue with the plan. I make a new join and only have to connect the point I want to make module. In this case, this is the first module. Program detect it, no? This is the second module, and this is the thread, the tree. If I join this, program think that is a module also, but this is if you have delayed the join point. If we force the 3D view, we have some incompatible. So let me delay the join. Delay the join. Maybe I didn't draw it, so I delayed. We have some compatible. Delayed lateral join. Delay join. A moment. So let me see. It's very important. I will profit to delete lateral wall to make it. So this is my template. Very important to know that if we have to use a orientation of this will be the entry in the module, and this will be the output. So when we are going to left to right, all the wall we have on the right hand will be made with this option. Let me choose new right lateral wall. So I will try it again. I will not make it very accurately, so to go fast. This is the right. I go to the plan and the left. Let's see. We have 3 modules in this case. Okay. Let's try to create a join with the plan, new join. Permit me to delay to put it not visible so you can follow me. I join in the point where I will have new module. Let's see. I have some incompatibility. Oh, this message is very bizarre. I start there. Initial right wing, initial left wing. Let me try to invert it. If it's not possible, I will load the default job. Delete join. Plan. Delete lateral wall. I will try to invert the configuration. Load. I'll try to put the left and the right as it, to see what's happened. It's not normal this. Capture, 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 capture. Capture, capture, and now we go to the right. Our new join. Something is bizarre. Well, in this case, to know, I will try. I will see it later. I want to. The solution is to make this input. When we see in the 3D, we see how we generate it. No, so let me close this and see the 3D view. Now I will hide the DXF and we remain with the information we need. First module, second module, third module. And we can verify, in this case, the different. In this module, we don't have the traffic. So we only have the traffic here. That's why we have this print of the traffic in different position, like this, finding the design of the road. No, this is a road. This is a middle module. We don't have traffic, and then permit to make connection. And the second one, with this configuration, we also have the possibility to control the strip load we add in the point we have. We can introduce it when this is made. Of course, we make the design of all. And we have the configuration like the first case we make. No, in this case we have more modules. No, so if we go to the forces and verify the different point, you see the second point, the third position. In this case, the traffic is out and we see the influence in this point. If we change it to the first position, is in this other point, and if we change the second, is in the center. No, so that will be very important to permit the program to take all conditions of the truck load we are introducing. And the same way, if we go to reinforcement, we see the hierarchical organization of all. We can start with the module. This is the first module. This is the second module. And we have a third module, which is the bigger part. Any of these modules, we can see the top, we can see the bottom slab, reinforcement, or a section reinforcement. If we go to the left initial wing, we have also the possibility to see the different partition of the analyze section, no, to make analysis. Because this is the presentation of this module, no, and the way they work. If you have question, you can make. For me, is enough. No, for the program was designed to be simple. No, it's not a complex program. When we are making case, we are very different. We don't have math foundation. We have to use CYPECAD and to know how to share or to use the scheme of the level, how to create different type of footing. No, but in this case, the box culvert is a specific type of structure, which element we already talked about. We are forced to have a mat foundation, a slab at the top, and optionally we can have wings, and we may have division to reduce the span in order to make it suitable for the case we are analyzing. Question?
Method? Is it using finite element?
Yes, use finite element. That's why when I am seeing the result, we see it like this way. So if you choose to see the discretization, you can see it according to these forces. If we make the output, so. This point program will give also in this let's see, you see result left wall give you the numeration of point of node, so you can follow the result. Normally this is not usual, but you see that the base is finite element. In the case, I said in the starting that the design of the module is being made by finite element, and the design of the wings is being made by a cantilever method. It's not finite element. It's a bar. We have a pressure, and we have bending moment, shear force, and we can design it. Understand this point?
Yes.
Okay.
By the way, is it also taking account the moving load?
The
moving load.
No, in the case of the wings, we take account only the infill load, because normally the wings have the proposal to avoid the soil to block the entry. You don't put load on top, so we only take account the infill load. The traffic load it will act in the module. We call module the center configuration of the slab, the mat foundation, and the external wall.
So you are in the module itself. Does the program taken into account the moving load?
Yes. Yes. That's why I show you like this. You see, load case. You see, I'm showing you in the moving load. This is the truck 1 in the position 2. You see where it act, no? In the center. So the design we take account. If I try to show the truck 1 in position 2, it will act in another different position. You see, this and the truck 1 in position 3 is outside, it's not on top. So that's why the influence is more in the corner. No, of course, this is the very big possibility of the program, no, to analyze that. So if we go to the track 3, we see this position. If we change it, we see how it acts in different points, no, of the wall. No, the center of the slab. Of course, this is the how to say the task, no, of this, no, to take account on the module of all elements of the module according of the position. It seems that there are some questions here. Let me see. There is a question, no? They make are train load supported? They are supported if you define it. Are train load supported? You can let go. Yeah. Close. We go to the edit windows. In this case, I give truck load new because I want to introduce a new one. I select a start point, I select an end point. So program give me some possibility. This one, this one, this one. If I don't have my case, I have the possibility to create it. So you have to create, maybe with AutoCAD or with Excel, the print of the train you want to create, the machine of the machine where it will transmit the print. No? So you have the section and you draw it and the load you want to transmit. When this information is being made, of course, you have something like this. And you decide the number of points to be. Let me change a simple one like this. This is a truck. Like this. So you decide the position you want to distribute for the line you introduce. You see? In this point, from year to year, I want 4 position. If you want more, the more position you put, more accurate. If you want to move the distribution line, more you go out of the module, menos influence you will have, no, for element. So with this possibility, you can generate all type of truck load, no? Okay, let me see. So it seems that were another question.
Is that all the hatchet? The hatchet area is the wheel load.
Repeat.
In the drawing just now for the traffic, the box, the square area that is with a color, is that the wheel load?
Yes, the print. The print of element will transmit the load. In more code, they try to make it a approximation of a rectangular element. No, so that's why when we make edition of this one I introduced, you see, this is the print of the element, who in this case a mobile crane. This is a mobile crane, no? So it's similar. So the print of any of the tire. It will be made, we can edit it to know it will be made in an area of 65 centimeter for 65 centimeter. And we have a load, a punctual load of 45 ton, which is being transmitted in this point. So with this way, you can create any type of truck load or make approximation of train load or what, anything you need. The program have some type we are being introduced, but we have not all the type of all the type, no? So that's why we give this possibility to create and archive it in the library to reuse it another job. No? When you spend time to create a special truck load, you archive it in the file to reuse it in another job, of course. Well, I think with that is enough for today. Glad to meet you, and if you use program, you have a special question to make, we'll be to available to respond. Okay.
Moment. Kepada para peserta, ada pertanyaan lain? Kalau itu di dalam chatnya ada link yang bisa download programnya ya. Jadi bisa download demo programnya, bisa dicoba. Just now we have the link to download the program, right? Ada pertanyaan dari peserta lain? Bisa lewat saya juga, WA ke saya bila mana perlu, Bu Ciliong ya. On your side, you have any other question, Antonio?
No, I don't have any question. This is to use. No, you have to use the program. And more you use program, more you understand the philosophy and what the philosophy. You see that it's a specific program for specific use. No, that. It's a specific program for specific use, but we cannot only resolve problem of both curves, canonic for way to use it, and where we are looking about something different that we don't want math foundation, it will not be a box curve, no? That's why I try to explain when I start making the presentation. So these are all we have to remember, no? To use the program.
All right. It seems that we don't have, you are finished, right?
Yes, I'm finished, of course.
All right. Kalau tidak ada pertanyaan, if there is no further question, probably we close the webinar. Terima kasih kepada yang sudah ikut, kepada para peserta. Ada pertanyaan, mungkin bisa WA ke kami juga, ke saya ya di nomor WA saya 0816 806649 0816 806649. Selamat sore kepada semuanya. Kita akhiri meeting hari ini. Nanti 2 minggu lagi ada lagi lanjutannya. Bisa ikut kembali ya. Terima kasih. Oke, Antonio. So, thank you.
Thank you for assistance and see you next.
Yeah, see you next time. In another 14 days, 2 weeks time.
Okay.
All right.
Bye.
Bye.
Bye. Thank you. Bye.
Bye. Bye.
Di atas itu sudah poin Pak, atau bisa di atas itu? Gitu. Ya, sudah tapi kena air dia. Enggak. Kalau besok pagi bisa. Oh, besok pagi bisa.
Salam, hati-hati.